Hello everyone, welcome back to my channel. I'm Purnima R, currently pursuing at Sri Venkateshwara College of Engineering in BE Cloud Sim. Today I'm going to discuss about analysis of completely randomized design and randomized block design that is come under mathematics for CSE stream. Firstly, we move on to experimental designs in statistical analysis. Experimental designs are crucial in statistical analysis as they provide a framework for conducting experiments and collecting data in a structured and controlled manner. They ensure that the collected data can be reliably analyzed to draw meaningful conclusions and make informed decisions. The choice of experimental design depends on the specific research question and the nature of the data being collected. Two common types of experimental designs are the completely randomized design and the randomized block design. Uh, these designs differ in their allocations of treatments and the control of extraneous variables, each having its unique strengths and weaknesses. Now we'll see introduction to experimental designs. Experimental designs are the blueprints that guide researchers in conducting their studies. They provide a framework for systematically manipulating variables, controlling extraneous factors, and collecting data to test hypotheses. The goal is to establish a causal relationship between the independent variable and the dependent variable. By carefully designing experiments, researchers can minimize bias, increase the validity of the result, and draw more reliable conclusions. The experiment designs are divided into four parts: control, replication, randomization, and blocking. Control. Experimental designs aim to control extraneous factors that might influence the outcome of the experiment. This can involve using control groups, randomization, and other techniques to ensure that the observation effects are due to the treatment and not other variables. Replication. It is essential in experimental design to ensure that the observed results are not due to chance. By repeating the experiment multiple times, researchers can increase the reliability and generalizability of the findings. Next is randomization. Randomization is a key principle in experimental designs. It involves assigning subjects to treatments randomly, which helps to eliminate bias and ensure that the groups are comparable. This increases the likelihood that any observed differences are due to the treatment effect. The last one is blocking. Blocking is a technique used to experiment designing to control for extraneous factor that can be influenced the output of the experiment. Next, we move on to completely randomized design, that is CRD. In a completely randomized design, the experimental units are randomly assigned to different treatment groups. This ensures that each treatment group is as similar as possible in terms of extraneous factors, reducing the chances of bias. The CRD is a simple and versatile design that can be used in a wide range of situations, making it a popular choice for any researchers. The completely randomized design is divided into four types that are defined treatments, random assignment, applied treatments, and measure outcomes. Define treatments. First step in a CRD is to define the treatments that will be tested. These treatments represents the independent variable or the factor that will be manipulated in the experiment. Random assignment. After defining the treatments, the experimental units are randomly assigned to the treatment groups. This ensures that can group is as similar as possible in terms of extraneous factors, reducing the chances of bias. Third is applied treatments. Once the experimental units have been assigned to the treatment groups, the treatments are applied to each group. It is important to apply the treatment consistently and under the same condition to ensure that the Only difference between the group is the treatment being tested. And the fourth step is measure outcomes. After the treatments have been applied, the outcomes or dependent variables are measured for each experimental unit. The assumptions of CRD is normality, homogeneity of variance, independent of observations. It is crucial to verify these assumptions before performing any statistical analysis. If these assumptions are violated, the results of the analysis may be unreliable. Normality. The assumption of normality says that within each treatment group should follow a normal distribution. This assumption is important for the validity of ANOVA test, which relies on the assumption of normality to accurately estimate the p-values. Homogeneity of variance. The assumption of homogeneity of variance states that the variance of the data within each treatment group should be equal. This assumption is important because it ensures that the ANOVA test is comparing the means of groups with similar variability. Violating this assumption can lead to the inaccurate conclusions about the difference between group means. Independent of observations. The assumption of independent uh, observation states that the observation within each treatment group should be independent of each other. Next, we'll move on to analysis of variance, that is ANOVA in CRD. The analysis of variance ANOVA is the statistical method used to analyze data from a CRD. ANOVA tests the null hypothesis that there is no difference between the means of the treatment groups by partitioning the total variability in the data into components attributable to different source. ANOVA can be determine whether the observed difference in means is statistically significant or simply due to the random chance. The ANOVA table summarizes the results of the ANOVA test. The F static is a measure of the ratio of variance within the groups. Interpretation of ANOVA results in CRD. The interpretation of ANOVA results depends on the p-value. If the p-value is less than the significance level, the null hypothesis is rejected. This means that there is sufficient evidence to conclude that there is a difference between the means of the treatment groups. The F statistic provides a measure of the effect size, indicating the strength of the relationship between the treatment and the outcome variable. Post hoc tests such as Tuckey HSD or Bonafironi correction are often used to determine which specific treatment groups differ from each other. Significant difference. If the p-value is less than the significant level, we reject the null hypothesis. This means that there is sufficient evidence to conclude that there is a statistically significant difference between the means of the treatment groups. This indicates that the treatment has a significant effect on outcome variable. No significant difference. If the p-value is greater than the significance level, we fail to reject the null hypothesis. This means that there is insufficient evidence to conclude that there is a difference between the means of the treatment groups, that the treatment does not have a significant outcome variable. The randomized block design, RBD. Randomized block design is an experimental design that is used to control for extraneous factors that may influence the outcome of the experiment. In an RBD, the experimental units are first divided into blocks based on the extraneous factor. Then within each block, the treatments are randomly assigned to the experimental units. This design is particularly useful when there is a known source of variability that can be controlled by blocking, leading to more precise estimate of the treatment effects. A randomized block design is divided into four parts: blocking, random assignment, treatment application, and outcome measurement. Blocking. First step in RBD is to block the experimental units based on the extraneous factor. This involves grouping the units into blocks that as homogeneous as possible in terms of factor being controlled. For example, if each is the factor being controlled, the experimental units could be blocked by the each groups. Second is random assignment. Within each block, the treatments are randomly assigned to the experimental units. This ensures that each treatments group within block is as similar as possible in terms of the extraneous factor, reducing the chances of bias. Treatment application. The treatment are then applied to the experimental units in each block. It's important to apply the treatments consistently and under the same conditions to ensure that the only difference between the treatment groups within a block is the treatment being tested. And the last one is outcome measurement. After the treatment have been applied, the outcomes or dependent variable are measured for each experimental unit. The assumption of RBD are normality, homogeneity of variance, independence of observation within blocks. Normality. The data within each treatment group within a block should follow a normal distribution. This assumption ensures that the ANOVA test can be accurately estimate p-values. Homogeneity of variance. The variance of the data within each treatment group within a block should be equal. Independent of observation. The observation within each treatment group within a block should be independent of each other. Analysis of variance in RBD. It is similar to the CRD. ANOVA is used to analyze data from an RBD. The analysis of focus on testing the null hypothesis is there is no difference between the means of the treatment groups while controlling for the blocking factor. ANOVA partitions the total variability in the data into components attributed to different sources such as treatment, block, and error. The F statistic and p value in the ANOVA table indicate the significance of the treatment effect. The last is interpretation of ANOVA results in RBD. The interpretation of ANOVA results in RBD depends on the p-value for the treatment effect. If the p-value is less than the significance level, the null hypothesis is rejected. This indicates a significant difference between the means of the treatment groups after controlling for the blocking factor. The F statistic for treatment measures the effect of size. The ANOVA results can be help to determine if the treatment has a significant effect on the outcome variable, even when controlling for the extraneous factor used for blocking. Post hoc test can be used to further investigate the difference between specific treatment groups within the each block. So that's it. Thank you for all.